welcome to a video about latent heat. To change a solid to a liquid, called melting or fusion, and to change a liquid to a gas, called boiling or vaporization, requires the input of energy. This energy breaks bonds between atoms or molecules, but doesn't change the temperature and is thus known as latent heat. The amount of latent heat required depends upon the nature of the substance, specifically its latent heat capacity, and the mass of the substance, and is calculated using this formula here. Latent heat equals mass times latent heat capacity. During the change of a state from a gas to a liquid, condensation, or from a liquid to a solid, freezing or solidification, heat is released due to the formation of bonds between atoms or molecules. In stage 1 physics, we'll undertake some experiments to determine the specific heat capacity or latent heat of different materials, which we'll have a go at next lesson. You'll also need to be able to describe and explain latent heat and solve problems using the given formula here. So, energy is absorbed at melting point and at the boiling point of water, but this energy doesn't change the temperature of water until a certain threshold is reached. This energy is instead used to overcome electrical forces of attraction in hydrogen bonds. So if you were to heat some ice that its temperature started down here, you'd be heating the solid ice all the way until 0 degrees, and between this original temperature here and 0 degrees, you've got a steady increase in temperature. The gradient is diagonal, so it's a steady increase. But by the time you get to 0 degrees, there's a flat period where the temperature doesn't increase, but more heat is still being added. You reach a certain threshold, and then the temperature of what would now be water starts to increase and increase steadily again. Then you get to boiling point, where the temperature again remains constant at 100 degrees for a while, so more heat is still being added, but the temperature is staying the same as 100 degrees until a certain threshold is reached, and then your vapor begins to increase in temperature steadily again. Energy is also released at the boiling point and melting point of water during condensation and during freezing. So if we were talking about going from water vapor, so gas, to a liquid, to water, and then to a solid, so to ice. So if you're just going in the reverse direction of what's outlined here. But at boiling point and melting point, even though energy is being continually released, the temperature of the material or the temperature of water doesn't change then either until the lower threshold is reached. So in this instance, energy is released when hydrogen bonds form, but the temperature of the liquid and gas water or the solid and liquid water doesn't change. During this phase here, both solids and liquids are present, and during this phase here, both liquids and gas are present. During these phases, only the solid, so ice, only the liquid, so water, and only the gas, so water vapor, are present on their own at those stages where the temperature is steadily increasing or decreasing. Latent heat is the quantity of thermal energy So heat that is absorbed or released during the change of state of a material at a constant temperature. And the latent heat is given by this rule here, and it's measured in joules because it's energy. The specific latent heat, which is this L here, it's measured in joules per kilogram, and it describes the quantity of heat absorbed or released per unit mass in changing state of material at constant temperature. So the magnitude is dependent also on the specific change in state occurring. So the latent heat of fusion occurs at melting and at freezing point, whereas the latent heat of vaporization occurs at boiling and condensation. I forgot to say just up here that mass is measured in kilograms, which is standard for physics. It's usually always kilograms for mass. So as an example, lead has a melting point of 327.5 degrees Celsius. You need to calculate the quantity of heat required to change the state of 3.75 kilos of lead from solid to liquid at 327.5 degrees, so at the melting point. If the latent heat of fusion for lead is 23,021 joules per kilo. So to do this, we'll just use our formula. We know that latent heat is equal to mass by the specific latent heat, and we're talking about melting point, so we're going to be using the latent heat of fusion, which is what we've been given here. Mass is 3.75 kilograms, and the latent heat of fusion is 23,021 joules per kilogram, that should be. So all we'll need to do is pop the mass into the formula and the latent heat of fusion into the formula, so 3.75 multiplied by 23,021, and our answer for latent heat will be 8.63 by 10 to the 4 joules. So that's the amount of energy or heat required to change the state of 3.75 kilos of lead from solid to liquid at 327.5 degrees. Another example, ethanol has a boiling point of 78.4 degrees Celsius. Calculate the quantity of heat required to change the state of a sample of 50 grams of ethanol from liquid to gas at the boiling point 78.4 degrees Celsius if the latent heat of vaporization is 8.38 by 10 to the 5 joules per kilo. So very similarly, we'll just use our rule, latent heat equals mass by specific latent heat, and we're talking about boiling point here, so we're going to be talking about the latent heat of vaporization, which is what we've been given. So this is 8.38 by 10 to the 5 joules per kilo, and our mass is 50 grams, which is equal to 0.05 kilograms. So all we need to do is pop this in, so mass is 0.05 kilos, latent heat is 8.38 by 10 to the 5. Therefore, our latent heat will be 41.9 by 10 to the 4 joules. So this is the amount of energy required to change the state of 50 grams of ethanol from liquid to gas at 78.4 degrees. The last example is bromine as a boiling point of 59 degrees Celsius. 4.7 kilojoules of heat is released when 25 grams of bromine changes from gas to a liquid at 59 degrees. Calculate the latent heat of vaporization of bromine. So we're talking about going from a gas to a liquid, so we're talking about condensation, therefore we use the latent heat of vaporization. So Q is equal to mass by latent heat of vaporization. To find this, we just have to rearrange, so latent heat of vaporization is going to be equal to Q divided by M. We know that Q is 4.7 kilojoules because that's how much heat was released, and our mass is 25 grams, which is 0.025 kilograms. So our latent heat of vaporization is going to be 4.7 kilojoules, which is 4.7 by 10 to the 3 joules, and divide that by mass, which is going to be 0.025 kilos. So popping that into your calculator will give you an answer of 1.88 by 10 to the 5 joules per kilo. So that's the latent heat of vaporization of bromine.